So I'm going to review sections 1 through 3 in preparation for your quiz. So section 1 and 2, we talked about solving systems of equations by graphing, substitution, and elimination. And then in section 3, we took a look at word problems associated with systems of equations. So when we are solving a system of equations by graphing, we are looking for the point where the two lines intersect. So when you're given a graph of two equations, you find their point of intersection. And then you want to pay attention to the scale of the picture you're given to make sure you're writing the point correctly. So if I look at my scale here, my point of intersection is at the point 2, -1. Our second example, if we look, our two lines are parallel. They're never going to intersect, which means we have no solution. If you are given a system of equations and it tells you to graph them to determine the solution, you're going to want to use Desmos. So you graph both lines in Desmos. Okay. And then you're going to do the same thing that we did on the previous two examples. You're going to look for the point of intersection. So for y equals 4/3 x minus 3 and y equals 1, the solution is the point 3, 1. And for the equations 2x plus 3y equals -12 and 5x minus 3y equals -9, their point of intersection is the point -3, -2. Next, we're going to look at solving systems of equations algebraically. So this is substitution and elimination. So you may be told to use a specific method to solve a system of equations, or you have the choice. So I want to go over the best method to use given what a system is set up like. So our first system of equations is -3x minus 3y equals 3 and y equals -5x minus 17. Now this equation is set up for substitution because one of our variables is already isolated. Okay. We have that y equals -5x minus 17. So what I'm going to do is I'm going to plug that in for y in our other equation. So -3x minus 3 times -5x minus 17 equals 3. Distribute the -3 in parentheses, so it becomes plus 15x plus 51 equals 3. Make sure you're paying close attention to when you distribute a negative into a set of parentheses. Combining like terms, we're going to get 12x plus 51 equals 3. Subtract 51 from both sides, and we get 12x equals -48. Divide both sides by 12. And we're going to get x equals -4. Now that we know what x equals, we want to plug it into one of our original two equations to solve for y. And the nice thing about substitution is you can plug it into that equation that's already isolated. So -5 times -4 minus 17. We get 20 minus 17, so y equals 3. Okay. On a short answer question, you are more than welcome to leave your final answer in this form, x equals y equals. You can also write it as a point, -4, 3. Just make sure you remember to put parentheses around your point and you write it in the correct format, x, y. So next we're going to take a look at an example of elimination. So we have the system -6x plus 6y equals 6 and -6x plus 3y equals -12. So there's a couple things I look for in trying to decide which variable to eliminate first. I look to see if there's a variable that already has opposite signs. and I look for a variable that I can eliminate by multiplying only one equation. Now, sometimes both of those criteria are met using the same variable, other times they're not. I think the more important criteria to look at is the one where you can eliminate a variable by only multiplying one equation. So in this case, both of my variables x and y have the same sign. So I'm going to look for the variable that is easier to eliminate. And in this case, multiplying only one equation works for eliminating x or y. But if I look, my x's already have the same sign, the same coefficient, which means if I want to eliminate x, all I have to do is multiply one of the equations by -1. And it doesn't matter which equation I multiply by -1. I'm going to go ahead and multiply the second equation by -1. So the first equation stays -6x plus 6y equals 6. The second equation becomes 6x minus 3y equals 12. So remember, with elimination, you always add the two equations together. The x's will cancel. 6y plus a -3y is 3y. 6 plus 12 is 18. Divide by 3, and we get y equals 6. Okay. Now that I know what y is, I'm going to plug it into one of the original two equations to solve for x. I'm going to plug it into the first equation just because there are less negatives. So we're going to have -6x plus 6 times 6 equals 6. So we get -6x plus 36 equals 6. Subtract 36 from both sides, and we get -6x equals -30. Divide by -6, and we get x equals 5. So even though we solved for y first here, when I write my final solution as a point, it's still x comma y. So my final solution written as a point is 5, 6. So we're going to do two more examples. So in our next example for substitution, we have -5x plus y equals -3 and 3x minus 8y equals 24. Now one of our variables isn't already isolated here, but in the first equation, I can easily isolate y by adding 5x to both sides. So we end up with the equation y equals 5x minus 3. Now I can use substitution and plug that into the second equation. So we get 3x minus 8 times 5x minus 3 equals 24. Distributing, we get 3x minus 40x plus 24 equals 24. -37x plus 24 equals 24. Subtract 24, and we get -37x equals 0. Now, a lot of people tend to think that this solution is no solution, but I still have a variable. A variable can equal 0. 0 divided by anything is 0. So x actually is 0, which when I plug into my first equation, -5 times 0 plus y equals -3, gives me that y equals -3, because -5 times 0 is 0. So you can have 0 as a solution for x or y. Okay? If you're solving by substitution or elimination and you think the solution is no solution or infinitely many solutions, that only happens when both variables cancel. So if you end up with an untrue statement, like -37 equals 0, or 24 equals 0, or 2 equals 7, that would mean no solution because you don't have any variables left and you have two numbers that aren't the same. Whereas if both of your variables cancel and you're left with 0 equals 0, or 24 equals 24, or negative 37 equals negative 37, that's a true statement, which means the solution is infinitely many. Our next example for elimination is negative 7x minus 20y equals negative 14, and 2x minus 10y equals 4. So I'm looking, my x's already have opposite signs, which is something I always tend to look for. But in order to eliminate x, I would have to multiply both equations, which I try to avoid if possible. Where if I look at y, even though the variables have the same sign, I could make a 10y a 20y by only multiplying one equation. So I'm going to actually eliminate y by multiplying the second equation by negative 2. I do have to multiply by a negative here since the y's have the same sign, and in order for a variable to eliminate, they have to have opposite signs. So the first equation is still negative 7x minus 20y equals negative 14. Second equation becomes negative 4x plus 20y equals negative 8. Adding the equations together, the y's cancel. We get negative 11x equals negative 22. Divide by negative 11, and we get x equals 2. So now I need to pick one of the original two equations to plug x into to solve for y. And I'm going to go ahead and use the second equation because there are less negatives than the first. So we have 2 times 2 minus 10y equals 4. So 4 minus 10y equals 4. Subtract 4, we get negative 10y equals 0. So this would be another example of where people think that the solution is no solution. However, we were able to solve for x. You cannot solve for x and then get no solution. Because remember, I can divide by negative 10 and y equals 0. So my solution is the point 2, 0. Making sure to remember parentheses around the point. So our last section was applications of systems of equations. I would say the best place to start with an application problem is defining your variables, figuring out what you are solving for. So our first example says two angles are complementary. They add to 90 degrees. The larger angle is 3 degrees less than twice the measure of the smaller angle. Find the measure of each angle. And then it says hint, use substitution. So first I'm going to define my variables. I'm going to let x be the measure of the smaller angle and y be the measure of the larger angle. Okay. Now I'm going to go back through and look for information that tells me what my two equations are. And the first one comes from the first sentence where it says two angles are complementary, they add to 90 degrees. So I know x plus y is going to equal 90. Put that over here. X plus y equals 90. My second equation is going to come from the second sentence that says the larger angle is 3 degrees less than twice the measure of the smaller angle. So that means y equals 2 times the smaller angle minus 3. Remember, the order for subtraction does matter. Okay. I can see now why the hint says to use substitution, because our second equation is already solved for y. So I can plug it into the first equation and we get x plus 2x minus 3 equals 90, which becomes 3x minus 3 equals 90. Add 3 to both sides and we get 3x equals 93. And divide by 3 and x is going to equal 31 degrees. It is important when you solve a system of equations word problem that your final answer contain units. So now I want to plug that 31 into one of my original two equations. And one of my original equations is just x plus y equals 90. So 31 plus y equals 90. Subtract 31. And we get that y is 59 degrees. I could have also pretty easily plugged x into the second equation and done 2 times 31 minus 3. It's not like the second equation was super difficult to plug it into. It's just anytime I have an equation that's x plus y equals something, I'm typically going to use that to solve for my second variable. So next we have, on Monday, Tom bought 10 cups of coffee and 5 donuts for his office at the cost of $16.50. It turns out that donuts were more popular than the coffee. On Tuesday, he bought 5 cups of coffee and 10 donuts for a total of $14.25. How much was each cup of coffee? So I'm going to first define my variables as C is the cost for coffee and D is the cost for a donut. So my two equations are actually going to come from the 2 different days. Both equations are going to be associated with money. So 10 cups of coffee and 5 donuts cost $16.50, and 5 cups of coffee and 10 donuts cost $14.25. And I only want to solve for one variable here, the cost for a cup of coffee. And I'm going to use elimination, so I want to eliminate D, the donuts. So if I want to eliminate D, they need to both be the same. And I can easily multiply my first equation by -2 to make a 5D a 10D, and they have to have opposite signs, which is why I have to multiply by the negative. So we get -20C minus 10D equals -33. And our second equation stays 5C plus 10D equals 14.25. So when we add the two equations together, we get -15C equals -1875. Then we're going to divide by -15. And then we get a cup of coffee costs $1.25. And if I needed to solve for the price of a donut, I would plug that into one of the original 2 equations to solve for the donut. But I don't need to, so I'm not going to. Our last example says, flying to Honolulu with a tailwind, a plane averaged 152 kilometers per hour. On the return trip, the plane only averaged 104 kilometers per hour while flying back in the same wind. Find the speed of the wind and the speed of the plane in still air. So my 2 variables, x is going to be the speed of our plane, and y is going to be the speed of the wind. So we know that flying to Honolulu, they had a tailwind and it went faster. So that means the speed of the plane plus the speed of the wind combined to go 152 kilometers per hour. Flying back into the wind decreased their speed, so the plane of the speed minus the speed of the plane minus the speed of the wind equals 104. So the nice thing about our system is that it's already set up for elimination. My y's have opposite signs and they have the same coefficient. So I can go ahead and add the system of equations together, and we get 2x equals 256. We're going to divide by 2, and we get that the speed of the plane is 128 kilometers per hour. Again, remembering my units. Now to solve for the speed of the wind, I'm going to plug it into 128 plus y equals 152. Subtract 128, and y equals 24 kilometers per hour. So the last example I did, it's not a difficult system to solve, but it is a difficult system to set up since most people aren't sure what to do with the two different speeds. There is an example on the quiz like this last problem, so please make sure you have it written down on the quiz review so you can reference it on the quiz. As always, let me know if you have any questions.